Welcome to the Virtual Tutor Series on Core Mathematics for Senior High Schools. This is a continuation of the lesson on factorization of quadratic expressions. In this lesson, we cover the factorization of quadratic trinomials with 1 and 2 variables. I highly recommend that you watch our previous videos on algebraic expressions for a better understanding of this lesson. As always, take your book and pen, just sit back and relax as you follow along. Before we proceed, let's try to understand the following three key terms. 1. Quadratic expression. This is an algebraic expression whose highest exponent is 2. Examples are x squared minus 4 and x squared plus 7x plus 10. Number 2 is a trinomial. As the name suggests, a trinomial is an algebraic expression with 3 terms. For example, the expressions 5a plus 2b minus 7 and x squared minus 2x minus 24 are trinomials. A quadratic trinomial, therefore, is a quadratic expression consisting of 3 terms. In other words, algebraic expression consisting of 3 terms with a highest exponent of 2 is known as a quadratic trinomial. In this lesson, we will consider 2 main types of quadratic trinomials. Number 1, a quadratic trinomial that contains one variable, such as x squared minus 2x minus 24. And number 2, a quadratic trinomial that contains 2 variables, such as 6x squared plus 5xy minus 6y squared. Let's begin with the factorization of quadratic trinomials with one variable. A quadratic trinomial with one variable is of the form ax squared plus bx plus c, where x is the variable, a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. We can factorize an expression of this form using the following steps. Step 1. Find the product of the coefficient of x squared, or a, and the constant term, or c. Step 2. Find 2 factors of AC, which will sum up to the coefficient of x, or b. Step 3. Replace b with the 2 factors. Step 4. Put the first 2 and last 2 terms in brackets and factorize each group separately. Let's consider the following examples. Factorize completely. Solution. Example 1 says we should factorize completely the expression 3x squared plus 4x minus 4 The first step is to find the product of the coefficient of x squared and the constant term. The coefficient of x squared is 3 and the constant term is -4. The product of 3 and -4 is -12. The second step is to find two factors of -12, which will sum up to the coefficient of x. The coefficient of x is 4, and two factors of -12, which will sum up to 4, are -2 and 6. The third step is to put -2 and 6 in place of 4. This produces 3x minus 2x plus 6x minus 4. Actually, we haven't done any magic to the expression, as you may have already observed. What we have essentially done is to break down the expression into 4 terms to facilitate easy factorization using the method of grouping. To get the original expression, you just need to sum up -2x and 6x, giving 4x. Now, the fourth step is to put the first 2 terms and last 2 terms in bracket and factorize them separately. For the first group, we have the common factor of 3x squared and -2x to be x. X into 3x squared is 3x, and x into -2x is -2. For the second group, we have the common factor of 6x and -4 to be 2. 2 into 6x is 3x, and 2 into -4 is -2. At this point, we put the common factors in each group in bracket and set it against the common term in the bracket. So we have into bracket x plus 2 bracket closed as against into bracket 3x minus 2 bracket closed. Example 2. X squared minus 2x minus 24. Step 1. Let's find the product of the coefficient of x squared and the constant term. The coefficient of x squared is 1 and the constant term is -24. The product of 1 and -24 is -24. Step 2. Let's find two factors of -24, which will sum up to the coefficient of x. The coefficient of x is -2, and two factors of -24, which will sum up to -2, are -6 and 4. Step 3. Let's now replace -2x with -6x and 4x. So we have x squared minus 6x plus 4x minus 24. Step 4. Now let's put the first two and last two terms in brackets and factorize each group separately. The common factor of x squared and negative 6x is x. So the first group factorizes into x into bracket x minus 6. Again, the common factor of 4x and negative 24 is 4. So the second group factorizes into 4 into bracket x minus 6 bracket closed. Let's now put the factors in bracket and set it against the common terms in the bracket. So we have into bracket x plus 4 bracket closed as against into bracket x minus 6 bracket closed. Example 3. 5x squared plus 13x minus 6. Let's follow the same steps. The coefficient of x squared is 5 and the constant term is negative 6. The product of 5 and negative 6 is negative 30. The coefficient of x is 13 and two factors of negative 30 which will sum up to 13 are negative 2 and 15. Therefore, we put negative 2 and 15 in place of 13. So the expression becomes 5x squared minus 2x plus 15x minus 6. Now, let's put the first two terms and last two terms in brackets and factorize each group separately. The common factor of 5x squared and negative 2x is x. So the first group factorizes into x into bracket 5x minus 2 bracket closed. Also, the common factor of 15x and negative 6 is 3. So the second group factorizes into 3 into bracket 5x minus 2 bracket closed. We now put x plus 3 in bracket and set it against 5x minus 2. Great. This should suffice for the factorization of quadratic trinomials with one variable. Let's move on to the factorization of quadratic trinomials with two variables of the form ax squared plus bxy plus cy squared, where x and y are variables. A is the coefficient of x squared, b is the coefficient of xy, and c is the coefficient of y squared. We can factorize an expression of this form using similar steps in factorizing quadratic trinomials with one variable. So for the first step, we need to find the product of the coefficient of x squared and y squared. For the second step, we find two factors of the product of x squared and y squared, which will sum up to the coefficient of xy. For the third step, we put these two factors in place of the coefficient of xy. And for the fourth step, we put the first two and last two terms in brackets and factorize each group separately. Let's consider the following examples. Factorize completely. Solution. Example 1. 6x squared plus 5xy minus 6y squared. Step 1. We find the product of the coefficient of x squared and y squared. The coefficient of x squared is 6 and the coefficient of y squared is negative 6. So the product of 6 and negative 6 is negative 36. Step 2. We find two factors of negative 36 which will sum up to the coefficient of xy. The coefficient of xy is 5, and two factors of negative 36 which sum up to 5 are negative 4 and 9. Step 3. We then put negative 4 and 9 in place of 5. So our expression becomes 6x squared minus 4xy plus 9xy minus 6y squared. Step 4. We now put the first two and last two terms in brackets and factorize each group separately. The common factor of 6x squared and negative 4xy is 2x. 2x into 6x squared is 3x, and 2x into negative 4xy is negative 2y. Therefore, the first group factorizes into 2x into bracket 3x minus 2y bracket closed. The common factor of 9xy and negative 6y squared is 3y. 3y into 9xy is 3x, and 3y into negative 6y squared is negative 2y. So the second group factorizes into 3y into bracket 3x minus 2y bracket closed. At this point, we put the common factors in each group in bracket and set it against the common terms in the bracket. So we have into bracket 2x plus 3y bracket closed as against into bracket 3x minus 2y bracket closed. Example 2. 12p squared minus 24pq minus 15q squared. We have the coefficient of p squared to be 12 and the coefficient of q squared to be negative 15. Therefore, the product of 12 and negative 15 is negative 180. The coefficient of PQ is negative 24, and two factors of negative 180, which sum up to negative 24, are negative 30 and 6. Putting negative 30 PQ and 6 PQ in place of negative 24 PQ, we have 12 P square minus 30 PQ plus 6 PQ minus 15 Q square. We now put the first two and last two terms in brackets and factorize them separately. The common factor of 12p squared and negative 30pq is 6p. 6p into 12p squared is 2p, and 6p into negative 30pq is negative 5q. So the first two terms factorizes into 6p into bracket 2p minus 5q, bracket closed. The common factor of 6pq and negative 15q squared is 3q. 3q into 6pq is 2p, and 3q into negative 15q squared is negative 5q. Therefore, the second two terms factorizes into 3q into bracket 2p minus 5q, bracket closed. At this point, we put the common factors in each group in bracket and set it against the common terms in the bracket. So we have into bracket 6p plus 3q, bracket closed, as against into bracket 2p minus 5q, bracket closed. Well done. This brings us to the end of today's lesson and the lessons on factorization of algebraic expressions. In our next lessons, we will cover factorization of algebraic fractions. Kindly like and share this video and also subscribe to the TVTL's YouTube channel in order to receive notification on future videos. Thank you for watching and see you in our next video lessons.